Hello, my name is Neil Mumal. The purpose of this video is to pair it with a pull request that I'm about to submit for eventuous. So recently I've been kind of exploring using eventuous with SQL Server as the event store, and I already have submitted some pull requests to improve the schema that I saw, um, maybe some opportunities to improve it. But I'm going to contribute something else that I feel like will help the long-term support of SQL Server as the event store. So without further ado, just kind of pop over here to my draft PR, and I'm not going to read this, but I wanted to show the files and talk about the process, especially for people that might not be familiar with Microsoft database project and what that would have to offer and what I'm basically contributing. Um, so I have one commit here that I've squashed down, but a bunch of new files. And I just would want to talk through them so that the maintainers, understand what's happening here. So just from the top down, there's a couple shell scripts here for some Docker stuff that I built, which is why get attributes changed. A new set of packages are added to directory packages props, specifically two for static code analysis, which I'll get into, and one for some DAC thing from Microsoft. Um, Solution file changed to add two new projects. Added a new get fit config just to make it nice on my end, since we have where I use some local feeds as well that were kind of getting in the way. So this new get config can be used or can be ignored, but doesn't hurt to have it. So if we just collapse down what you see on the left here, you'll see I've only added two directories in the source SQL Server directory. One being this eventuous SQL Server database, the other one being this eventuous test SQL Server database. So we'll look at the first one first. So the purpose of this database project is to add, it adds this SDK, which is a great SDK. Use it for many things, but effectively this database project is simply a place we can dump the full schema of the SQL Server database that we have. So the schema you define, which I'm calling eventuous, I know that eventuous allows you to dynamically set the schema if like for whatever implementation you're using eventuous with, but for the sake of this project, I'm just calling schema eventuous because I know that is the default if you don't specify it. So, but then elsewise here we have our table definitions. So checkpoints, messages, and streams, and then all of the procedures. And these are identical to what's currently in the scripts folder of the SQL Server, but got to know that those script folders are the migration scripts, and they're not like proper syntax for a project such as this, which a project like this gives you a lot of tooling that like those just like raw scripts that we have don't really give us. So there is kind of like a duplicate of these scripts now. One is for the sole purpose of the migrations that exist currently today, and then this one is will be solely purposed for static code analysis and testing. And obviously, it's just a little bit nicer from the build side, which I'll get into. But yeah, so we have procedures, schemas, tables. This is the static code analysis file I will mention, which is a place you can put suppressions for certain things. So there are right now 4 suppressed things that the analysis found that there are possibly issues here. Like for example, checkpoints table has an nvarchar as the primary key. That's defined here as a no-no. So these rules are all pretty clearly defined. That didn't open for some reason, but oh, that's why. So this is just saying that primary key should avoid using GUIDs, wide varchar columns. So this is more of a smell, which we could clean up, but I just wanted to describe that these are 4 rules that right now are kind of being violated, but we're suppressing them because I don't want to contribute changes to the schema in this PR. This PR is totally just for the purpose of like setting this framework up. And stream messages is the type we have as well. Additionally to those parts of this project, which actually those are like the core parts of the project itself, that how how they will be built. But additionally, we have a couple things, which is this Docker file, which I named Dockerfile DB from DACPack. The purpose of this is to actually build this project in a Docker image. It will get a DACPack as a result. We also add SQL package, which is a tool from Microsoft. We unzip it, we install it, we make it executable, and this is the entry point script that's over here. This is the make my person a bit smaller. This entry point script I'm highlighting is the entry point shell script right here, and that's what the Docker image is doing. And then this entry point script is actually setting up our SQL Server database. So we're going to use where are we at? Yeah, we are effectively waiting for the server to start up. We're setting our password. Let me jump back. If we look at the Docker file, the first layer of this is using the .NET SDK. The second layer of this is using a SQL Server 22 image. And so what that gives us then in the entry point is actually we are spinning up a SQL Server database in Docker, setting password. This is all dumb stuff like password, default password stuff. Doesn't matter. This is just for the purpose of getting this set up and going. Down here is where the magic happens, where we actually are using SQL package to publish our DACPack to this database, and some exclusions passed to this tool, and some logging. So I will demo this. Actually, I will demo this right now. I wasn't sure about the flow of that, but if we look really quickly at another file I provided, which is a README, it just talks a little bit about how to use these tools. So from this, from a different directory that I didn't get to yet, we run Docker Compose up, and technically you don't need to do detached mode. If we do, we can just run, we can just look at some logs here of this. So right now the database is spinning up. These logs above are from an earlier test I did of this. But we can look here now, this is complete, and there's a bunch of stuff happening with the testing framework that I didn't get into yet. But effectively now we have a healthy SQL Server database running here. And if I just show you SSMS real quick, this is a connection to this server with that password. And if we look at the Object Explorer, you will notice we have our tables. We have our procedures all out here automatically. That's all through the tooling of the DACPack and the project that I created. So jumping back to the pull requests and continuing on to get into the nitty gritty as why this is helpful. So the testing project, if you're not familiar with the framework T-SQL-T, this is a testing framework for a SQL Server. And so that's the purpose of this project. So it is another CS proj using the same SDK, but it's set up a lot differently. There are tests in here that you'll see look odd, maybe if you're not familiar with the framework. But this is where you define your unit test. So this specific test is a test on the checkpoints table. And checkpoints in the T-SQL-T framework, checkpoints is actually a schema, and you actually create that schema with this this code here. We're running t=t new test class, and you pass it a name, and that name results in a schema being created. So you can kind of think of a test class and a schema being the same thing. For each schema, you can create a setup procedure, and within that procedure, you do whatever you need to. In this example, we're faking a table, the table under test, and then every test that runs automatically will first run the setup table, or a procedure rather, without needing to specify at the top here. You notice there's no execute checkpoints.setup. It's just redundant. It's just inherited. You get that out of the box for every test. But if just trying to understand what this test is doing, we're applying the primary key constraint, because by default, when you fake a table, no constraints are applied for this testing framework. So you have to intentionally, explicitly apply constraints, whether they be primary, foreign key, unique. You have to explicitly apply those through this mechanism. So here we're just basically turning on that primary key constraint, and then I'm declaring a message that I expect to happen, and then I'm inserting into the checkpoints table with the same key twice. So this is an ID of 1-1. And the result of this is that the test will succeed, or the assertion will succeed, when a violation of the primary key happens. So that's a really quick summary of one type of test. There's many types of tests, and this is a test on a table. There are also tests I wrote for the procedures, which are more important, arguably. So this is an append events test, which obviously this is a sort of the key procedure that I'm sort of concerned of testing of, and just for long-term support. And there's not a lot of tests in here, but this is just single test to assert that at the end here you'll see we assert equals table is some thing that's common in t=t, and we're basically asserting that our insert into the stream happens. So we're inserting this kind of dumb event, and we are going to assert that after we execute append events, we're going to gather the stream data that would have gotten created from that procedure. Then we're going to basically gather the messages that also got created from that procedure, and then we assert that they are what we expect. Okay, so that's a really quick summary of what the tests look like. There's tests in here for every table and every procedure of eventuous, focusing on sort of like happy path mostly, and the easier things to test. There are definitely still some things that could be tested with some of the the optimistic concurrency exceptions that can happen. When you build this project in Visual Studio or whatever, with .NET, you, as part of the build, there is a post-deployment step, and that's true for all database projects. You define the post-deployment work you need to happen. In this example, I'm running this generate deploy shell script, and all this does is it generates another SQL file based on all of your tests, which it's and it's in a different format. It's in like a SQL command format, which that's get ignored because it's auto generated, so you don't see it here in the diff, but I can show you that to you as well. So that's sort of the guts of this project. Oh yeah, by the way, here's the get ignore, where we're specifically ignoring this post deployment script that gets generated. So switching to Docker, there are Docker parts to this project as well. So the first one being one called eventuous dbc t=t runner. This guy also uses the .NET image. It pulls the database projects in, both the main guy and the test project, and the directory props and NuGet config for the purpose of the build. And then we build the database project, which has a project reference to the other database project. And that project reference results in both the projects building, both of them getting their build artifacts out. So that's why, yeah, you'll see .NET build. We build the test project, and then again we have a SQL Server image, and we continue. We again install SQL package, and again this time we have to download something extra. So this image also downloads tsqlt, the testing framework, which is here. We are adding a tsqlt zip download. We unzip it. We get a few important files from that zip per the instructions of that framework, so that we can run them on this Dockerized database. We have our entry point here, which is a different entry point than before. And we're copying all the things we need out to the image. And then the entry point is here. Now this is connecting to the same database that we created earlier. So effectively here, we're just publishing now our tests to the same database that we created earlier with like the real eventuous schema on it, so that we can run the tests. So there's some different modes that you can run when you run the commands. You can run all tests. You can run a class by name. So earlier I showed you the checkpoints class. You could run just those checkpoint tests, as opposed to this, we'll run all the procedure tests and all the table tests. Or you can run an individual test, so a single test within a class. On CI, you'd want to run them all. If you're debugging or building a new test, you might want to run it by name. It's built this way, just sort of for some flexibility. We install tsqlt. We again use SQL package to publish the database project. This is the same database project I talked about earlier. This is like the eventuous one. This does get published in this image just so that we get a fresh, even if you have a detached database container running, you can execute this entry point multiple times as you create new tests or edit the schema of eventuous, and get a fresh, make sure you're working on a fresh copy of both projects. So it deploys the real database just like the other image does. And then again, we used another SQL package hit where we deploy the tests. So then once they're all finished, we call the final guy, which is a running test. We execute, and we execute the tests here. So that is a lot of info if you're not familiar with these projects. So let's jump over to the command line where I showed you earlier, where we spun up our database, and back to my README file as well to help me, because a lot of this it's just good to have a reference. So here is a example that we are going to run a class of tests. So this is going to Docker Compose run build eventuous DB test runner. That's our name that we've set in that in our compose file, or in our Docker file. And we're going to run a class. Remember, that's going to run the whole set of tests within this class. So let's go. Oh no, not running. So let's try this. Oh, I'm not in the right directory. That's why. Which is a little sometimes a little bit tricky when you jump around a bunch. There we go. And let's copy this. So a lot of this is cached, but copying the database stuff into the image, building the database projects, getting the DAC packs, deploying those to the database, downloading T-SQL-T, deploying that to the database, and then executing the T-SQL-T tests. And so here you see the output of the tests. There's 2 tests within the append events test class. They both passed. We can run all of them just for fun. And this again is doing all the same things, just redoing it, right? So we get our fresh copy of tests. So on CI, I can envision this being nice because, well, this is how we use it in my experiences. You can also execute a T-SQL-T tool that gets an XML output of these test results when you're done, when after the tests have been run, and then you can parse those and dump those into like a JUnit or XUnit format so that a tool like ADO or GitHub could pass or fail the test. Now, I haven't done that in GitHub before, but it's possible, and that's where I want to go with this tool for eventuous. That's sort of the full demo. I guess I'll just show a few things here. So what happens if a test fails? It would look like this. We're just gonna mess it up, right? We're just changing some data in the expected set, and this will break the test. I can also change the schema on the actual database project to break the test too. Which, let's see, what would be... Trying to think what might be a good way to demo that. Let's say we make a terrible mistake and we forget to put something in here. Developer makes a terrible mistake and changes the schema so that whoopsies gets saved into the messages table. So as you can see there, we're kind of doing a couple things at once here, but you can see there that this append events test failed because that assertion I made is wrong. So now it's just going to demo that if you make a change to the schema and run these tests, that will also fail. And again, this is copying the now saved project into the container and rebuilding it. So you can do it. You can do it live like this. You might notice this is taking longer. That's because the image layer of the Docker image was previously cached because we didn't need to rebuild the project. It could identify that there were no reasons to rebuild it. It was the same as the previous run, but this time it identified that there was a reason to rebuild that project because we made changes to the schema itself. And so here you can see that we now failed this other test as well because we didn't get the right stuff into the table. So let me just quickly make sure that I talked about everything I wanted to here. The README file that I'm working off of is here within the test Docker set, because this is where you sort of like run the tests from this directory, whereas the other directory of Docker is solely for the purpose of getting that image that deploys the database project, but we don't really need to use that in this example. Yes, I believe that's it. Yeah, so I hope this demo was helpful um, for the purpose of me merging this PR. Um, Happy to talk about it more or commit more if we need to, or work with the maintainers to plug it into CI, because I think that's really the benefit here. Um, the benefit being, as people iterate on SQL Server schema, which there probably isn't going to be a ton of iterations, but these things will be in place to make us feel good about the code changes before we deploy them. Thank you very much for your time.